when you are discussing about this binomial distribution today, initially what you need to understand is when you are working out with this distribution, we come across with two types of distribution. First is binomial and second one is Poisson. But the main problem where the most of the students ask, how do we understand whether this question is a binomial question or that this is a Poisson distribution? Later on we learn about Poisson distribution for that. Right. The first way is you can understand that there should be two options in the outcome. The experiment should proceed with two outcomes. Right. Okay. Then, for example, this one. So you can say, toss a coin. So what are the outcomes you can see? Head and tail. So it's a binomial distribution. So we have only two outcomes, right? Then this one, what can you say about this one? Throw a dice. Throw a dice. Is this a what you call binomial or not? So if you throw a dice, sorry, I wrote it the wrong way. Throw a dice. Right. Okay. So it can be 1, 2, 3, 4, 5, 6. There are 6 outcomes. It's not binomial for this. But this one. Throw a dice and side 6 is expected. So in this case, you can see, though you get this one 1, 2, 3, 4, 5, and 6. All these ones are not 6. Not 6 complement of 6. So though you get several outcomes, the final outcome is only 2 of them. So it's come up with the binomial distribution. Right. That's the first fact, first property we need to understand about a binomial distribution. You should get 2 outcomes in this case. The second one is probability of events remain unchanged. That's the first condition where it happens. Right. Okay, this one. So you can see what kind of situation. Suppose that you can see, draw a ball from a bag with 2 red and 3 green balls. Draw 2 balls with replacement. Okay. So if you do this with replacement, so the first bag contains 2 red and 3 green. So you can obtain a red ball or a green ball. This is 2/5 and this is 3/5. Again, red and green. So since it's replaced, for the, so like the what do you call the ball you observe in the first one, it's already replaced over here. So this one also 2/5 and this one also 3/5. This is 2 red and 3 green. So it's turned up to 2/5 and 3/5. So the probability remain unchanged. So the red probability is same. The green probability also same. Right. So this one, so it's a come up with this condition satisfies. Okay. The second condition is draw 2 balls from a bag with 2 red and 3 green without replacement. without replacement. If it is without replacement, but the initial condition is just like this. We draw it from 2 red and 3 green. So you can obtain red bead or a green bead. This is 2 over 5 and this is 3 over 5. Then when you come to this point, red bead is already taken. So there is only 1 red and 3 green. So now from here only, we obtain this values. 1 over 4 and 3 over 4. If you come across over here, it takes 2 red and 2 green. Red and green, so it is 2 over 4 and 2 over 4 would be the answer for that. Now you can see the probability here, it changes. The probability of changes with the event rate. So the probability not remain unchanged. For such situation, again, we cannot apply binomial distribution because to apply the binomial distribution, the probability should remain unchanged. So this is called, from another term, how do you say this? Make it like this. The other way you can say it in sometimes as an answer you mentioned, events are independent from each other. Events are independent. Independent. Okay, right. The next condition is, what is the first condition? First condition is there should be 2 outcomes. What is the second condition? Probability remain unchanged or the event should be independent. Yeah. The third condition is there should be a fixed number of trials. There must be a fixed number of trials. Then you can say the experiment should be done for a specific number of time. Number of times. For example, if you consider a dice is thrown 10 times. 10 times. So it's you can use this condition. There should be specific number of times they put it. So they mention the dice is thrown until 6 appears. Is there a fixed number of trials? Because you know that at the first time when you put it, sometimes at the first time itself, it can 6 can occur. Sometimes after 100 times only 6 came up. Sometimes after 1,000 times only 6 came up. Just like what you have, you play Ludo. When you play Ludo, first time you 6 comes, there is no specific time. Right? So that's what you can come across with that. That is a second condition, but we need to understand with that. Right? Can say number of chess moves to finish a game. To finish a game. So this is not, sorry, this is not, sorry. These ones are not. It's not binomial. To make the number of chess moves to finish a game. So it's not fixed for them. So there is not a fixed number of trials are there. So that is how you need to understand with that. Is that clear? So those are the basic facts where we need to learn about the binomial distribution. Right? Okay. So these are the initial steps where we should know about binomial distribution. Right? Okay. Right. So in this case, you can write the distribution of binomial distribution. Distribution. The distribution comes like this. This is the way. So initially we can work like this. You can see this kind of situation. Yeah. A coin is tossed for 5 times. The coin is tossed for 5 times, and the number of heads appear is recorded. Right? They mention the coin is biased, so probability of head appear is 2/5. Okay, so in this case, you can see there are two options, head or tail. Head or tail, head appearance is, the probability of head appearance is 2/5. Therefore, probability of tail appearance is 3/5. That's what we need to understand. Okay. Then the question is, find the probability of uh, only one head appears. Okay, this is a factor to understand. Let's look at this. You're tossing it for 5 times. You're tossing it for 5 times. Then the first time you can get a head. You can get a head. And all other 4 times you get tail. That's the first option. This possibly happens. Then the first time can head, tail occurs. All other second time head and all the three would be tail. It's possible. Tail, tail, head, tail, tail. This is a possibility. Other option, how to get it? Tail, 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 head on tail. This is the first part A question. Then tail, 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 head. So this question, so what is the probability over here? Head appearance is 2/5 times of 1 times of 3/5 times of 4. Probability of this option. This is the first. The first way it can occur. This is the second way it can occur. This is the third way it can occur here. Now here also what is said? 2/5 to the power 1, and others were 3/5 to the power 3/5 to the power 4. All other things, just this one and this one and this three also the same thing. Then if you want to get probability of number of tails is equals to 1, the number of head appears is 1, is how much? So you can say 2/5 times of 3/5 to the power 1, 3/5 to the power 4 times of, there are some kind of a combinations over here. You can multiply by how much? Initially we write it here, number of 5 into 5. Then what is the answer? So you can say this is 5 times of 2/5 times of 81/625. 625. Turn up to this bit. 0.0864. We can get this answer very easily, right? Then the next one, part B, they can ask you find the probability of only 2 heads appear. What is the possibility? First one can head and second one can tail. Sorry, first two both can be head initially. You can see the both can be head and all other 3 can be tail. Okay, this is one option. What is the second option? First one head, next one tail, again head, again tail, again tail. That one also you get 2 heads. Understood? Is that clear? Then this one, head, tail, tail, head, tail. Is also possible. Head, tail, 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 head. This also, sorry, head. Yeah, this is possible. Again, this can be tail, head, head, tail, tail. This is also possible. This is tail, head, tail, head, tail. Like that. There are a lot of combinations are there. Now you can see what is the probability over here. 2 over 5 to the power 2 times of 3 over 5 to the power 3. This one also same. All of them are the same, right? Isn't clear? Then if you multiply 2 over 5 to the power 2 times of 3 over 5 to the power 3 into number of combinations, you get the probability. You get the probability by multiplying this one. So this one you can write, this is the expected event. This is expected event. You get the, you count the number of hits. You count the number of hits. So this is the expected event. So this is the probability of expected event. Probability of expected event. Expected event. Make up your marked as P. Usually marked as P to the power how many trials? We expect we expect two hits. Number of expectations. Number of expectations. Expectations into 3 over 5 we can get number 1 minus P. 1 minus P means now 1 minus probability of expected event is 1 minus 2 over 5 is this. Okay, look at this. I have assigned P as what? Probability of expected event. The 1 minus 2 over 5 is how much? The 3 over 5. So you get this probability from that. Is that clear? Into this 3. How many total trials we have? 1 to 5. If you multiply this, I'll get as n. Sorry, I'll get it as k. So I'll get it as k. Exactly what I'm doing. K. 1 minus k. In my, sorry, not 1 minus. It should be total number is n minus k. Then into number of combinations.
That's for the modules.
Combinations. Then let's go ahead with this. So when you have, this is the probability of, this is distribution of a binomial distribution. We'll come up with the distribution and I'll show you. This is the basic of that how it came. So usually we write x is the random variable. X is having a binomial NP where x is the random variable. Random variable. This random variable means what is the expected event, what you have done about this experiment. You are tossing this coin, or sorry, tossing this coin, and what is the expectation? We get the number of heads. The random variable is number of heads. Understood? Right. B is the distribution. It's a binomial. Binomial distribution. This is a way of writing it with the distribution. This n is the number of trials. What do you call the number of trials? Number of trials means how many times you repeat this experiment. P is the probability of expected event. Expected event, which is given by this random variable. Okay, right. Now let's go ahead with this. This is the distribution. If it is so, you can write probability of x equals to k is equals to nck. From this equation only you get the combinations into p to the power k times of 1 minus p to the power n minus k. This is the formula to get the binomial distribution. From when you are working out the question, we'll understand this situation, right? So initially come up with the, over here, I am going to explain the same question from this methodology. Okay. So you can start get this one as example 1. Example 1. In this example 1, this is the distribution example 1 in example 1, right? Okay. Then this in this experiment, what we were expected from this experiment, You toss a coin for 5 times and you get the number of heads. So that is the random variable. But what is the experiment we are doing about? We just toss a coin and we expect the number of heads. So X is the number of heads. Number of heads appear. Then you can say this number of X appear is having a binomial distribution. How many times you repeat this experiment? We repeat this experiment for 5 times today, because you toss the coin for 5 times. N is the what do you call that? The random variable is the or number of heads appear. No? So we get the probability of appearing a head at one time today. But the probability of appearing head is 2/5. You can say it is 2/5. Always here the probability you should write with what? With the successive probability what you expect in this experiment. In the first part, the question they can ask, find the probability of only one head appear in this experiment. Then this is a way of writing it. Probability of number of heads appear is how much? It's equals to 1. That's the way of writing this equation. Okay. Then yeah, let's go ahead with this formula. If it is x equals to kn, what is n? It's this 5. C, k is 1, p is 2/5 to the power 1, 1 minus 2/5 to the power n is 5 minus 1. So you get 5 into 2/5 to the power 1 into 3/5 to the power 4. This is the final answer for this particular. Here. Let's see, and the same thing, it comes from here. You just do it, just enter from your calculator, you will get the answer 0.0864. Part B. What was a part B question? They are referring to find the probability of only 2 heads appear. Only 2 heads appear. And probability of number of heads appear is how much? Equals to 2. You can say then total number is n, from this one n is 5c2, 2/5 to the power k is 2, 1 minus 2/5 to the power 5 minus 2 is the answer for this. Let's go ahead with this. Then 5c2 times of 2/5 to the power 2 times answer is this bit. 0.3456 would be the answer for that. That's a way of obtaining the answer for this kind of a question. Right. Like there's a spinner. You know what I mean by spinner, and this is the red. Suppose that this is 120 degrees, and this is 60, and this is 90. This is red, and this is green. This is blue, and this is yellow. Right. So that just like it happens with it. So you can say spinner spins for 8 times. 8 times. Our question is find the probability of getting green for part 1 3 times, part 2 6 times, and after spinning for 8 times. For this case, what is the random variable? Random variable is what do you expect? What do you expect from this? Find the probability of getting green. So you can say number of greens obtained. number of green obtained. So you can say this one like this. So you can write x, the number of green obtains has a binomial distribution, number of trials. How many times you are repeating it for? 8 times probability. Probability of green is how much, Pute? The total angle is 360 divided by 60, Pute. So the probability become 60 divided by 360. That's 1 over 6. 1 over 6, Pute. Right. Then you can say the first one is part A. Probability of number of sixes. Number of sixes obtained is 3 times. X equals to 3. Second one. Probability of number of x obtained is how much? It's turned up to 6 times. That's the first way to find it. 3. How do you get it? Put how many times you are repeating it for? 8 C3 1 over 6 to the power 3 1 minus 1 over 6 to the power 8 minus 3. You can get this answer. This is 8C6 1 over 6 to the power 6 1 minus 1 over 6 to the power 8 minus 6 is the answer for that. Right? Okay. Then you can get this probability. So you can, if I get these values, it's turn up to 8C3 into 1 over 6 to the power 3 times of 5 over 6 to the power 8 minus 3 is 5. It's turn up to 0.104 is the answer. Then 8C6 into 1 over 6 to the power 6. So no, 6 to the power 6 times of 5 over 6 to the power 6 is 2 to the power 2. Let's turn up to this bit. 0.0000417 is the answer for that. That's the way of getting this answer. Let's do this. Yeah. The next step, know how to find some kind of like multiple probabilities in some any kind of a normal distribution. Suppose that X is having a binomial. Sometimes they call, sometimes B. Some books used to say B. Binomial. You will get 10 and probability is 0.2. That's the event we need to understand for the right. Okay. Yeah. Then the first case they can ask you is probability of x is equals to 2. This is pretty simple. You can say 10 C2 0.2 to the power 2 into 1 minus 0.2 is, you can say it's 1.1 minus 0.2 to the power 10 minus 2. So it's turned up to, if you work out this way, so you can say 10 C2 into 0.2 to the power 2 into 1 minus 0.2 is 0.8 to the power 10 minus 2 is 8. You get the answer 0.302. 0.302 is the answer for that. Right. Then if you need to find this probability of x is less than or equals to 2. If we happen to say probability of x is less than or equals to 2, you can do like this. This is the probability of x equals to 2 plus probability of x equals to 1 plus probability of x equals to 0. These are the events less than 2. It can be 2 times, it can be 1 time, or it can be none of the event can be present with that experiment. So it can 0 is there in this event. So how do we get this answer? So you can say 10C2 0.2 to the power 2. 1 minus 0.2 is 0.8 to the power 8 plus 10C1 times of 0.2 to the power 1 times of 0.8 to the power 9, because it's 10 minus 1, plus the next one is 10C0 times of 0.2 to the power 0 times of 0.8 to the power 10. That's the answer what you need to get with it. Understood? Right. So in this case, then we can say this amount we already found 0.302 plus the next value is it's done up to 0.268 plus the last one is it's done up to 0.107. Then you can get this value 0.302 into 0.7, sorry, plus 0.268 plus 0.7, 0.677, 0.677 is the answer for that. Is that clear? Right. Okay. Then the next fact they are referring is this way. The probability of x is less. Sorry, there's another way of doing this question, but you can get the help from your calculator. This is the way. So this is what you can do, right? Just this optional way. There is a different color to represent. Right? We can use this way. So we will get the probability of k. X equals to k. What is the probability with it? N C K p to the power k 1 minus p to the power n minus k. This was the formula. Understood? For a probability of x equals to k. Can you remember? Yeah. Right. Over here, what is n? We need to find what is n. N is, in this experiment, it's 10. So you can say 10 C K. P is probability 0.2 to the power k. According to this relationship, 1 minus 0.2 to the power 10 minus k. Okay, so this has to be varied from x equals to, we need to add the event for x equals to 1. 10c1. So 10c1 is k is a 1 value. You need to add this one for k equals to 1, for k equals to 2, and k equals to 3. We need to add them for k is 0, 1, sorry, k equals to 0, 1, 2, 3. For these three figures, we need to do this simplification. Understood, Pratik? For first here k equals to 2 value is here, k equals to 1 value is and k equals to 0 value is, and add them together. Therefore we can write in this way. You can write summation k goes from 0 to 2, because I need to add 0 value, 1 value, and 2 value with it, right? Okay, therefore you can write this is 10 c k 0.2 to the power k, 1 minus 0.2 is 0.8 to the power 10 minus k. You can get the help from your calculator from this way. You can use your calculator, and if you take your calculator, yeah, you can press shift with log button here. Then you may be getting a summation operation. You can fill up the top value with 2 and the bottom value with 0, 0. Then you can fill up this bracket value. Bracket value you can fill up with 10. You can write 10. We know how to enter C. How to enter C? Shift with division button. K. K is where to fill up with a variable. Usually over here is K, but in the calculator we don't have K. For the variable we apply X. To get apply X, what you need to do, put alpha. This is a bracket mark. You can see the X value over here. I think you'll be able to get this answer. All right. Okay. Alpha button with closing bracket. Can you remember how to get it? Is that clear? Right. Okay. Right. Then into 0.2 to the power, again alpha with closing bracket, alpha x. Go back into 0.8 to the power 10 minus alpha x. Okay, right. Then you get the answer. If you put it
Okay.
0.677, I think that's the same thing you get.
Mm-hmm.
This way even you can get it. Okay, right. Then let's do another, sorry, the next part of the question they can ask you this way. They might ask you to write probability of third part x is less than 2. In this sense, less than 2 means that 2 is not included. 2 is not included. Therefore, you can write this is probability of x equals to 0 plus probability of x equals to 1.
Yeah, sure.
That means over here we already knew these two figures. 0.107 plus 0.268. 0.107 plus 0.268. If you put them together, the answer is 0.375.
Okay.
375. That's how it comes. Then the next fact is put this way. They can ask you probability of x is greater than or equals to 3. Now let's see if you want to get this. The top value is 10. Therefore, you need to get the probability of x equals to 3, 4, 5, 6. It's kind of long. So you have to write, you have to add a lot of terms over here. Right. For that one, I will use some kind of a different technique for this. You know that what are the total elements here? 0 is there. 1 is there, 2 is there, 3 is there, 4 is there, 5, 6, 7, 8, 9, and 10. Right. Then we need greater than 3. Greater than 3 means which area? We are referring to this area. Isn't it? Right. Then if you add up all these elements, all these ones, what would be the probability for them? If you add them all these things, if you add them total probability that is equal to 1. So out of 1, if you subtract this bit, if you subtract this, you can get the required answer over here. So you can write 1 minus probability of x is less than or equals to 2. Then you can say it's 1 minus, we already found this answer for that. 677. 677, with that you get the answer. 1 minus 0.677. 0.323, yeah. 0.323. That's the answer for that. But is that clear? Right, that's great. Okay. Then the next part is right. Oh, the other alternative method for this. So you need to add them from where to where? 3 to 10. You need to add them from 3 to 10. Therefore, you can use the summation formula for this one as well. So you can put 10 C K, probability 0.22 to the power K into, that should be into here, 0.8 times of 10 minus K. We need to add them from where to where? You need to add them from 3 to 10, including 3 to 10. K goes from 3 to 10. If you do this one even, you get the same answer as what you gain over here. Hope you can understand how it came. Is that clear? The next method, next one is this. If you need to get, look at this method. If the equal 3 is there, 3 should be included in set, right? This other part of it. Okay, probability of x is greater than 3. Greater than 3 means that 3 is not there. 3 is not included in the set. That means this one's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? That means 3 is not included in the set. That means this bit is the bit what you need to get this, right? Then you can say this is out of 1, you can subtract the lesser portion for that. You can do it, yeah. So you can say 1 minus probability of x is less than or equals to 3. So you can say this is 1 minus, I'll just get this answer, summation k goes from 0 to 3, 10 c k into 0.2 to the power k times of 0.8 to the power 10 minus k. Okay, that's how it comes. So I'll just put it. This is 1 minus, this is a notation for that. 0 to 3,
Anyway, you have maybe
10
articles
C alpha x times of 0.2 to the power alpha x into 0.8 to the power 10 minus alpha x. From here you can get this answer. Okay, 0. This is 0.879. It's turned out to 1 minus answer. That is 0.121. 0.121 is the answer for that. It's a way of getting this answer. Okay, that's how we need to do this kind of questions. Yeah, so when you are discussing this question today, what you can see here is that x is having a binomial this, but here the probability was available, but this part of a probability straightforward we can't get it because calculator is not capable enough to work out with that kind of a higher operations. For this kind of situations, you're using a different technique for that. For that technique, we'll do it a bit later. For the moment, we'll do the first part of it. Right? X is having a binomial. We'll get 20, 20 and 0.4. Right. The first fact we need to find is probability of x is less than or equals to 5. So this is pretty simple. You can say summation k goes from 0 to 5, 20 ck 0.4 to the power k, 1 minus 0.4 is 0.6 to the power 20 minus k. So you can use the calculator to get these answers. Right. So you can say summation, it goes from 0 to 5, 20 c k into 0.4 to the power k minus, sorry, into 0.6 to the power 20 minus, 20 minus 20 minus, okay. Alpha, it comes with x in the calculator, but if you just do it, you see that answer is 0.1256. That's the answer for that. Is that clear? Hopefully fine. Right, okay. Then you happen to see x is less than or equals to, less than 5. If it is less than 5, now what you can understand is that 5 is not included. 5 is not included. Therefore, you can say summation k goes from 0 to 4, because this is literally similar to probability of x is less than or equals to 4, because 5 is not included over here. 20 ck, again same thing, 0.4 to the power k, 0.6 to the power 20 minus k is the answer for that. So so this value is 0.050, 051. Actually, it's 1.51. That's the answer for that, right? Then, if you need to find this part 2 and part 3, if you need to find probability of x is greater than or equal to 6, now if you started from 0, 1, 2, 3, 4, 5, 6, 7, 8, so on, it goes over here. Greater than 6 means, including 6, this part should be there. So this has to be removed out of 1, you get the answer for that. So you can say 1 minus probability of x is less than or equals to 5. That is 1 minus less than or equals to 5 value already found from here. 1, 2, 5, 6. That answer is 0.8744. Okay, right. Then the next fact, this is the point you need to understand. Probability of x is in between, we will get, so this distribution is 22, yeah, 20. Yeah. So it should be 10 after 15 to 10. Now, in this case, what you can get here is that there are a couple of ways you can do it. Either you can find, these are different ways. The first approach is you can straightforward add them from where to where. K goes from 10 and 15 should be included. Therefore, it's turned up to 10 to 15. You can say 20 ck, 20 ck, the x 0.4 to the power k, 1 minus 0.4 is 0.6 to the power 20 minus k. You can add these ones together. So you have to go from 10 to 50 and you can get this answer as well with it. Yeah. This answer is 0.2443 with it. Okay, or you can use this way as well. Because sometimes, if you use, there's another way we do it. That's because the table. From which we work out the table, we need to see how to get this answer. So here the values what we need is this way. It should be 8. This goes from here 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 goes on up to 20. So what are the probabilities we need? Including 10 and 15, the included value. 10 to 15. This is the set what we need. To get that set, I will get, because from the table we get the lesser region. Later on we learn how to get the table. We can do like this. I'll get the probability of x is less than or equals to 50. Get that whole thing. Out of that whole thing, which has to be removed with it, we need to remove this part out of that with it. If you remove it only, you get this intermediate value. Can say probability of x is less than or equals to 9. Then you can use the table for this table, or you can use the formula for this one as well. So,
which formula?
Sorry,
Which formula?
so this one, like this. You can put a formula somewhere similar to this. Okay. Okay, this slide can do it this way. X goes from 0 to 15, 20 is 0, 0.4 to the power x, 0.6 to the power 20 minus x minus summation x goes from 0 to 9, 20 c x, 0.4 to the power x, 0.6 to the power 20 minus x. You can get this answer in this way, right? Okay. Yeah, so this answer is 1 second, but it takes a bit of time. Yeah, this answer is 0.9996 minus 20 to 9. This answer is 0.7555. So 553. Then if you do this 0.9, sorry, 753. That answer is 0.2443. That one also you get the same answer. You can use any proceeding to do this question. Okay, but that's how to do it.